Welcome everyone to the first session of the CFD tutorial. Today we want to cover geometry preparation and mesh generation topics. Choose the fluid flow Fluent because later we want to do our simulation with Fluent. And now on the geometry we can right click, and from the import geometry we can import the STL file that we have, which is here a carotid. When the geometry is imported, now we can open it. We have a different options, the discovery, space claim, design modeler, but here we want to use a space claim. It's always important to prepare the geometry before doing a mesh. For example, when we have a complex geometry or when we have a sharp corner, we always have to smooth or regularize them. So from the autofix here, basically, we want to close the inlet and outlet of the geometry that we have. And if we choose the through from the box section, we can choose all whole geometry. So basically now we can see the inlets and outlets are closed, and it's very important step to do any CFD simulation because we want to apply boundary conditions on them. So any geometry for CFD simulation should be closed. Now again from the facets option, we choose regularize. Basically with the regularize option, we want to increase or decrease the number of points. We want to change the element size and the edge sizes, basically to smooth the geometry better, to remove the sharp edges, the sharp corners that we have. Here we have two options. One is angle threshold and one is the maximum edge length. For example, if you choose 1 millimeter and click on apply, then we see that the number of points of the geometry now are changed. You can always press Ctrl Z to bring the geometry to the main one that we imported and try different numbers for the maximum edge length to see how it affects the geometry. Now, when we press Ctrl Z, we see that we brought back the geometry to the main one. And now we can choose another value for the maximum edge length. You see that it's just drawing the geometry, and it's such a geometry we cannot use for doing any CFD simulation. So we just press Ctrl Z, bring the geometry back to the main, and then we can choose a better one. Now we have an idea that how it is affecting the geometry, so we can go with the 1 millimeter. It's not exactly very important to choose like 1, 0.5, because later with doing mesh we go for the real element size. The last step after preparing the geometry is to merge them as a merge faces. Basically we want to convert it to a solid geometry, so we have to choose the merge faces because in the inlet and outlet surfaces we don't want to see any more elements because we have to consider them as a one surface. Then we can apply boundary condition on them. So now everything is ready. We can close the geometry and then go for the next step, which is the mesh preparation. So now we can right click on the mesh, choose edit, and then we can open the Ansys Meshing. Now you can see the geometry is imported to the Ansys Meshing, and we have a closed geometry. The inlet and outlets are closed. The first thing is that we can choose always the unit to be millimeter because it's easier for the element size that we want to choose later and work with them. To start, we always need to generate a mesh. Here we can choose the element size to be 1 millimeter and generate the first mesh that we want to have. This step is just to evaluate the mesh and to see, okay, if the element size is enough for us, or if we have to change it, decrease it, increase it. Now you can see that the element size are a bit big, so we have to decrease the element size. This is one thing that we can understand. The next step is to choose the options that we want to use for generating the mesh. One option that we can add is sizing. Basically, with sizing, we have more control on element size and inflation, which is nothing just boundary layer. We also have to add the boundary layer mesh for doing a correct CFD simulation. With the sizing, and here from this section, we can choose the whole geometry and we can click on apply. And from the element size, we can choose any element size for the mesh in this body. So we can go, for example, with the 0.6 millimeter as the first estimation after generating the first mesh, that we found that the 1 millimeter was big. Now, from the inflation, we again have to choose the whole boundary and the whole geometry that we have. So the geometry, we click on the whole geometry and then we can click on apply. And of course, for generating a boundary layer mesh, we always have to choose the boundary that we want to generate mesh on that. So we have to select all the faces from the right click and then deselect the inlet and the outlet surfaces. Basically, we don't generate boundary layer on them. We have to generate the boundary layer on the wall of the geometry. So we deselect the outlet surfaces and the inlet. And then we can click apply. For the inflation, we can always choose any method. Here we choose total thickness. Basically, we consider the total thickness of the boundary layer to be 0.6 millimeter and the number of layers here is 5. We can always change that. Depends on the application and the geometry that we have. Now we can generate the mesh. So now it's generated. We can click on the mesh to see what we created for the mesh. Here we can see the boundary layer in the outlet surfaces and the meshes in the middle of the domain and also the inlet. We have the inlet for the inlet, the mesh for the boundary layer and for the domain. The next step after creating a mesh is to look at the statistic. One thing we can see is the number of elements that we have, which is here around 100,000 elements. Now, to do a CFD simulation, we have to choose the boundary. So we have to name the boundary. Basically, we can consider the name. We have to add name selection, and from the name selection, we have to choose the inlet and the outlet surfaces. But here we choose surface instead of the whole volume. We have a 2 outlet, 1 inlet. So we choose one surface, and then we can rename it as, for example, outlet 1. For this outlet that we have here. Now we go for the next one. So right click, we can insert another name selection and we can also rename it to the outlet 2. So the next step is to choose the surface. Again, we choose the option for the surface. We consider another outlet, click on apply. Now we name these 2 outlets and the only one is the inlet one. So we choose another name section. We choose the inlet and now it's all ready. We just need to rename it to the inlet because whatever you named here, you will see it in the Fluent. So it's also easy for you to name it here and then you don't be confused later for doing the CFD simulation. The only thing that we have to choose is the whole body as a plot. Basically later in Fluent, we also need to name the volume, the whole volume, and we should consider the whole volume as a plot. So again, From the name section, we can click on the name section, right click on the name section, and we can add another section. But here, instead of surface, we go to choose the whole geometry or the whole volume. And if we click on apply, so we also have this one later to consider it as a plot. And we just need to rename it. And we consider it as a fluid. So everything now is ready about the mesh. We just need to close the Ansys mesh and import it to the Fluent, which is the next step.